Hello everybody. Today we are going to learn about electron shielding. So in your Edmodo, go to the post that says electron shielding. We have the link for the reading. We have our practice questions, and we have my email you can send your answers to. So electron shielding has to do with ionization energy of an atom. So ionization energy is how much energy it takes to turn an atom, a neutral atom, into an ion. So this has to do with removing electrons. So in general, the ionization energy is going to increase as we move from left to right across the periodic table. So that is the general trend. There are several exceptions to this. So the elements of group 13 are going to have a lower ionization energy than the elements of group 2. Now, this is because of what we call electron shielding. So outer electrons are always going to be partially shielded from the attractive force of the protons in the nucleus by the inner electrons. So, for example, an example of electron shielding, we'll look at the lithium atom. So lithium has atomic number 3. So the neutral atom has 3 protons, 3 electrons. 2 are in the first principal energy level, so level 1. And then its valence electron is going to be in level 2. So the valence electron is going to be partially shielded from the attractive force of the protons in the nucleus by these 2 inner electrons. So removing that electron is going to be easier because of the shielding effect. Okay, it has less attraction to the protons because the other electrons, the inner electrons, are shielding it. So there's also going to be a shielding effect that occurs between sublevels within the same principal energy level. Okay, so an electron in the S sublevel is going to shield the electrons in the P sublevel. So the 2 S electrons are going to shield the 2 P electrons. 3 S electrons shield the 3 P electrons. Okay, 4 S shield the 4 P. So that's basically what they are talking about. So the electron being removed from an aluminum atom is a 3p electron. So that is shielded by 2 3s electrons as well as the innermost electrons. Okay? So the electron being removed from a magnesium atom is going to be a 3s electron. So the 3s, so magnesium is a group 2, and aluminum is a group 13. Okay, so we got a little sidetracked from this explanation here, but magnesium is group 2, aluminum is group 13. So aluminum should have a higher ionization energy than magnesium, but in magnesium, it is a 3s electron, which is only going to be shielded by the inner core electrons. Aluminum is a 3p electron. It is shielded by the 2 3s electrons and the inner core electrons. So there's more electron shielding. So the electron that gets removed from aluminum, that is going to be that is going to have minimal attraction to the protons in the nucleus and is going to be easier to remove. So that's how its ionization energy is less than that of magnesium. All right. So there's another anomaly between groups 15 and 16. Atoms of group 16 are going to have lower ionization energies than atoms of group 15. Okay. Now this one goes back to Hund's rule. So Hund's rule is where they fill each orbital one at a time, going in the same direction. So in a nitrogen atom, we have 3 electrons in the 2p sublevel, and they're all unpaired electrons. In the oxygen atom, there are going to be 4 electrons in the 2p sublevel. So we have the 3 that would normally be unpaired, but one of them is now paired. So we have 2 unpaired and 2 that are paired. Because of this pair of electrons and because of the repulsive force of these 2 electrons between each other, it is going to be easier to remove an electron from the electron pair in the oxygen atom than it is to remove an unpaired electron from the nitrogen atom. So make sure you finish your questions and turn them into me.